evening, our agenda again, just like what I've mentioned earlier. Yeah, we're going to extend this, or we can create another session for our tutorial session tonight, Renel. So it is fine. Yes, we're going to extend as we cover these topics. Okay. So for this evening, we have parse trees, axiomatic semantics, and recursive descent parsing. And I believe both chapters 3 and 4 are both challenging. So first, we go to grammar. I've pulled up here our slides. So before we continue, which particular part of chapter 3 you find challenging? I know which particular part you find challenging, okay? Surely you find axiomatic semantics challenging. How about the others? For the 16 students who are present right now, 16 out of 100. You are 100 in your class, by the way. So axiomatic semantics ang gusto niyong pag-usapan natin? How about grammar? You're good with grammar? Okay, sige. Take your time browsing slides so that I'll know what are those things which are challenging. Okay, so we have the pairwise disjointness test. It's in the state diagram. How about other answers? I'm just waiting for your answers before I continue, okay? So another answer here, we have ambiguity, case denotational semantics. Regarding your question, Shirley, the quiz will be somewhat similar to the practice problems I've given you, but not necessarily the same. So kamukha lang, or same type of your quiz, pero hindi exactly the same. Malay nyo, baka may kunin tayong ibang tanong doon, kaya okay din na sagutan niyo din yung problem. It wouldn't hurt you if you give time to answer your practice problems, and later we're going to answer some of the items in your practice problems para at least magkaroon kayo ng idea how you have to do certain things. Okay? At ayan, yung i-discuss ko lang ngayon, syempre, meron tayong session ngayon because I want to help you regarding your quiz on Saturday. So syempre, pag-uusapan natin ngayon, malamang sa malamang, malabas sa quiz sa Sabado. O, kaya, yan, buti nandito kayo, at least alam niyo kung ano yung malamang nalalabas. Di ba? Yung mga hindi ko i-discuss, hindi mo siguro lahat, pero kung i-discuss natin ngayon, lalabas yan sa quiz. So siguro yung hindi natin i-discuss, hindi yan lalabas. Ayan, you have an idea. So, sige, let's continue. Punta muna sa grammar. So, I want to see who among you are having a hard time dealing with grammar. Alam mo kasi, importante itong grammar. Because a grammar here, in our slides, it is a formal definition of syntax of the language. For example, sabihin natin, English language, di ba? Hindi naman sapat na alam mo yung mga English words. You also have to know how you form English words and how do you know how to form English sentences. Siyempre dapat tama yung grammar, tama yung structure, di ba? Tama ba ako doon? Is it right? So then sa programming language, it is not enough, you know, the individual syntax, individual commands, but you also have to know how to form them. And for us to know how to form them, meron tayong tinatawag na grammar. Ang bawat programming language, meron silang corresponding grammar. Okay? So, tandaan nyo, every programming language has its corresponding grammar because the grammar are the rules which tell us how to form the proper syntax of our programming languages. Okay? O, sige, punta na tayo. Paano tayo mag-grammar? Punta na tayo sa dito. Ayan, sige. Example na tayo. Punta tayo sa example. Nawala ako bigla. Ayan. Yeah, so, our example, let's say, here is our grammar of a simple, sabihin natin, simple English grammar rules. So, yung grammar natin, alam naman natin, yung English, for a sentence, it is composed of the subject and predicate, di ba? So, we can see here, dito yan, sentence, produces subject, predicate. Di ba? Tama naman yun. And then a subject can be composed of an article and a noun. So, rules talaga siya. These are your rules. Then predicate can be composed of a verb, another article, or a noun. Verb, article, noun. Okay. Now, how do we determine kung proper yung syntax ng isang proper yung syntax niya? Again, if you can produce a valid parse tree or a valid derivation for a particular set of constructs, we can say na walang syntax error doon. What do I mean? Let's say for example, ito yung ating example 1. Say, the boy ate cake. Another example, say, boy, girl. Okay. So sa unang tingin, which of these two forms valid syntax of the English language? Yung una, di ba? Tapos alam din natin, here, that the second example, boy, girl, is not valid. So we can say, the second example, may syntax error dito. Tama ba? Yung una, walang syntax error. Yung pangalawa, may syntax error siya. Anong boy, girl? O, diba? Ano naman yung sentence nun? Unlike with number 1, eat the cake. Diba? So, syntax error yun. So, ngayon, paano natin masasabi? Paano natin patutunayan? Kasi alam natin pag binasa natin, valid itong isa hindi valid. So ngayon, paano natin patutunayan what will be the evidence that the first one is valid and the second one is valid? Can anyone tell everyone how do we produce the evidence? So using the rules, okay. Yeah, that's right, we use the rules. Now, how do we use the rules to produce the evidence? Yes, parse tree or derivations. If you've read your particular forum entry ko before, if you've read that, I said that it is easier because parsing is a graphic, it's just a visual representation. So how do we produce one? So to produce a parse tree, kailangan natin malaman, we need to know what is our starting point. Okay? So what is our starting point? So by the way, before we continue, in a particular rule or production, like this one, we have this one is the left-hand side, and this is the right-hand side. Diba? Obvious naman bakit. And the left-hand side is what you call the non-terminals. Have you encountered that before? So we can actually say that the left-hand side or the non-terminals, it can serve as the category, something like that, but not really category. But you can think it. We make an analogy. A non-terminal can be a category. So do you get it? So it is a category which produces something. So the left-hand side produces something, and the something is on the right-hand side. Now, on the right-hand side, it can be another non-terminal or no. Terminal, ito na yung actual constructs natin or the actual tokens. Okay, do you get it? So are you still there? Okay. So I just want to clarify that. Now, okay, so we know the difference between a terminal or a non-terminal. So I have to make sure that you understand that. Here, question. I have a question. How many non-terminals do we have here? I just want to know, just want to check out if you understand that. So we have 1, 2, 3, 4, 5, 6, 7. Nasaan yung dalawa? So we have, according to some, the answer is 8. To others, 6. Sa iba, 10. So 8. Paano naging 8? Nasaan yung dalawa? Where are the other 2? So if I'm going to ask you how many non-terminals we have here, again, non-terminals simply two categories. So we have here 6. Take a look on the left-hand side. Yes, left-hand side, and then unique yung pagbibilang natin dito. So we have sentence, subject, predicate, verb, article, and noun. Now, if we want to produce a parse tree to check if it has syntax error or it is valid, we have to select one of these non-terminals as your starting point. Hindi ka basta-bastang pipili lang ng non-terminal. Dahil non-terminal siya, sige, I can produce a parse tree here. So we have to select a starting point. Now, how do we select a starting point? Does anyone know how we select the starting point? Anyone? Walang gusto sumagot. Okay, first in the list of NT. Okay, Ron. Very good. Set S. The answer is set S. So, saan yung set S na yun? Saan ang galing yun? So we go to the previous slide here. So that's right. So that's why it is important that you have to understand this, read this. Because a particular grammar is composed of four components actually. We have sigma, with terminal symbols or the tokens that we have. N is for the set of non-terminal symbols, which I mentioned earlier. P, productions or rules. This is all of this. Yeah. So all of these are your productions or rules. Okay. Then set S. Now what is this set S? A distinguished non-terminal S, the start symbol that specifies the category being defined. Usually, this is defined. Defined, or let's say in a practical sense, in your quiz on Saturday, this is usually given, the start symbol. Because the start symbol, it is the start of, this is your starting point, this is the root. So every programming language, the symbol is already defined. Okay, so do you get it? So for every programming language, the start symbol is defined. And practically speaking, if you are going to solve this, for example, in your exercises, or this is again usually defined. Or defined as a sigma. Sigma is defined, N is defined, P is defined, S is also defined. And then, given those four components, it is up to you to produce the parse or the derivation tree. Again, I really took this opportunity to have this tutorial session because you're not only going to use what you will learn tonight in your quiz on Saturday, but you are also going to use this. You have to know this for your final project. So we're actually hitting two birds with one stone. So this is not only for your quiz, but you have to know this because this for your final project. But again, I think I mentioned before that you are going to write your own programming language. And of course, if you're going to write your own programming language, you have to define the grammar. You have to define the rules which govern their own programming language. And I want you to remember that. Okay, so if you understand grammar, you're on your way. You're on your right track. You are on the right track. Sorry. Yes, we're going to one programming language. Yes, I'm going to specs. Actually, I'm going to send it this week, the project specs, so that you can read on that. And then perhaps you can start your writing the grammar of your project. Yeah, your finals, for your question, Mike, your final project, your finals, your final exam. So, in exchange of that, you have to do well for your final project. Okay? Don't worry, we're going to set another session discussing your final project. If ever you have clarifications, then we can immediately address that. Okay? So we go back here. The boy ate the cake. So how do we produce the... What do you think is the symbol? Sa slide ba natin? Start symbol. So what do you think is the start symbol? Again, logically speaking, logically thinking, of course, is the sentence. So let's put it here. So sentence. So sentence. Okay, then sentence will produce subject and mamaya ko na lalagyan ng line. Subject and predicate. Parang gumagawa dito ng puno, kaya nga siya parse tree. We put here the line. And then, for subject, subject has article and noun. So article and noun. So subject produces article and noun. Nag-i-edit tayo dito ng linya. Okay. So it's just like we are doing gradual replacement of the non-terminals. So we replace the non-terminals by the right-hand side. And then if you have questions, feel free to interrupt me. Then predicate, we have verb, article, and noun. Naputol na. Ang verb, article, noun. Kumpletuhin ko lang para makita nyo. So, are you guys in the process here of what we're doing right now? Okay, that's nice. That's great to hear. Article, and then after article we have the boy. Hindi ko na lalagyan ng line. Hirap maglagay ng line. Okay. You just put the lines there. Well, that is for example 1. And we were able to produce a complete parse tree for the sentence, the boy ate cake. Now, for the second example, boy, girl. That's the syntax that we have, boy, girl. So are we able to produce a parse tree? So if we take a start symbol, yes, we start with sentence, obviously, and a sentence is composed, or sentence produces subject and predicate. So it's impossible actually to generate boy girl, to generate a parse boy or boy girl, isn't it right? Surely regarding your question, good point raised. You can make the choice if you want to use derivation or parse tree. But for me, personally, I prefer using parse tree. It's easier. But if using the derivation by one derivation rules, if you are comfortable with that, I have no problem with that. Okay? Mahala na kayong pumili kung ano yung mas okay sa inyo, mas komportable. But for me, I actually encourage using parse tree. Okay? Sige. Again, for example 1, we were able to produce a parse tree. For example 2, we weren't able. Sige. Next na tayo susunod. So malinaw na tayo dun, ha? So parse tree. And then, to write the grammar rules, we actually use B and F. Ito lang yung kanyang itsura. The left side, and then it is followed by 2 colons and equal sign, and then the right hand side, which can be composed of terminals and non-terminals. And also remember that the left side is always a non-terminal. hindi ka makakita ng terminal sa left side. And that's impossible. Kasi yung terminal, ibig sabihin ng terminal, ito na yung, diba, yung ibig sabihin ng salitang terminal, ito na yung katapusan, diba? Ito yung nasa dulo, ito na yung ending, diba? So kung siya na yung nasa dulo or ending yung terminal, wala na siyang karugtong. Unlike non-terminal, may karugtong na. Okay? So again, the left-hand side will always be a non-terminal, and the right side can be a terminal, a non-terminal, or a combination. Sige. Punta na tayo sa... Saan tayo pupunta? So again, derivations, you've mentioned that, and I'm glad that many of you have studied this. Derivations. Then, okay. Saan natin to? Properties of a parse-tree. Punta tayo dito. I want to actually emphasize the last point. If A is the non-terminal labeling some interior node and x1, x2, xn are the children of that node from left to right, then A produces x1, x2, xn is a production. Honestly, do you understand this point, the last point? I want to know. Again, we have 4 properties of a parse tree. And the last point, I want to actually know if you understand that. Okay, leaves are from left to right as well. Actually, you've stated it clearly. Sa pool mo. Ay, tama ka. Yeah. It's like if you are given a parse tree like this one, okay? So we have this parse tree. And let us relate what Carl is saying. So leaves are read from left to right as a... For example, if I ask you to produce production just using the parse tree, or if I ask you to produce the rules using the parse tree, you can actually produce them. Just like what Carl was saying, you can do that by reading the leaves from left to right. Di ba? So parang reverse engineering lang siya. Binaliktad lang natin. Earlier, we are given the rules for our productions and then we produce the parse tree. But this time, you are given the parse tree and then you can produce the rules. Okay, diba? So binaliktad lang natin. Medyo nakaka-intimidate yung pagkakasabi dito sa fourth point. But it's just, yeah, the leaves are read from left to right to produce the corresponding production. So, okay. O sige, sampulan na natin itong parse tree natin dito. So, what are the valid prudence or rules for this? O, pwede nyo naman i-type dyan. Practice lang. Ganda nagpo-practice din. Okay, so that is 1. B produces 0 and B. So by the way, hindi pala siya leaves. So, basta dito, you have your parent or yung magulang mo, and then you can produce the productions by reading kung ano yung mga anak niya. So not just the leaves, okay? Hindi lang leaves. Pero kung ano yung mga anak niya. Pero si B, anak ni B si 0 at saka si another B. Okay, so ba yun? So not only the leaves, yeah. It includes the leaves but also the internal nodes. So if we write the rules, it would be something like, wait. Okay, B. So tama yung nilagay ni Pokemon. So 0, B, and then yung vertical line na yan, anong ibig sabihin ng vertical line na yan? Just making sure if we're on the same page. Yeah, alternative, yes, or the pipeline or the vertical line, yeah. It indicates choice, it indicates option. So here we have two options or two alternatives for the non-terminal B. Okay, ayan. So yun lang yung ibig sabihin ng fourth point kanina. Sige, tayo, ayan, humahaba na yung ating example. Shirley, regarding, sige, bago tayo Shirley has this question. Para lang alam niyo din. Alam ng lahat. Lagay natin dito, ha? Wait lang. So, yan. Okay, ang tanong ni Shirley. Okay, Ron, wait lang. Sige, screenshot yun na muna. O Ron, yan, sige. Yan, screenshot yun na. This is our answer, right? B produces 0B or 1B or 0. Now, she was asking if this particular answer here on the left side, dito ko na nilagay, is right. So what do you think, guys, is the one? So repetition, iteration or repetition. So unfortunately, this is not a valid answer. I would just like to emphasize na merong ibig sabihin yung curly braces. The curly braces indicate repetition. Okay? Now, sige. Alright, something to ponder. A certain statement is generated by two or more distinct leftmost derivation or rightmost derivation. Before I ask this question, do you know what do leftmost derivation and rightmost derivation mean? So ano ibig sabihin nilang dalawa? Leftmost derivation, rightmost derivation. So as we can see here, leftmost derivation, we're the leftmost non-terminal first before we proceed to the next non-terminal. So it's just a way, or it's just a matter of replacement, which to replace first with the corresponding right-hand side. For the rightmost, of course, the rightmost non-terminal is also replaced. So now, what I am asking, if you are able to generate two or more distinct leftmost or rightmost derivation, what's the implication? Ano ibig sabihin nun? So that's a question that you can answer, actually. Kung yung tanong, so if you're able to produce distinct leftmost or rightmost derivation, what's the implication? Ambiguous? Talaga? Mark Ruel, you are right. So as long as the leftmost and the rightmost derivations produced the same parse tree, it's all right. Kasi ba yun? If you can produce the same parse tree for both the leftmost and rightmost derivation, because it is really possible, nangyayari ka, then it's all right. There's no problem with that. Now the problem is yung kayo na yung sinagot, ambiguity, or being, the grammar being ambiguous. If you are able distinct parse trees. Kanina, different derivations but same parse tree. That's all right, based from our slide here. But if you are able to produce two or more distinct parse trees yung pinag-uusapan natin dito. What's the implication? It's not all right. Because of ambiguity. Ngayon, tanong ko ito sa inyo. You can answer. Bakit problema ang ambiguity? Why is it a problem? Or why is it a concern for us? Ambiguity. Bakit natin ito problema yun? Bakit siya problem? Pwedeng sagutin, ha? Okay, so tama ang sinabi ni Derek. You are right. Malilito ang compiler or yung interpreter. Ano yung gagawin? Di ba? It will be a problem during the interpretation or the compilation phase. If you have read chapter 2, you have to know those two concepts, interpretation or compilation. Anyway, going back to ambiguity, it's hard. Anyway, thank you, Brian, for raising that up. I'm going to create a new session, okay? $11 na, pero sisipag nyo, no? Ganda yan. Okay, you're still there. So, we have 8 persons who are present. 10 na pala. 10 persons. That was quite fast. And miraculously, I just figure out that WizIQ is now recording our session. Yay! So it's now being recorded. Naka-chapter 3 pa lang naman tayo. May chapter 4 pa tayo mamaya. And let's target by 12 we're done. Siyempre, iba sa inyo may trabaho. May mga buwas. Sige, patuloy na tayo. Masa na ba tayo kanina? Ang work pa bukas. Sige. Basta dapat 12 tapos na tayo. Kung saan man yung marating natin. Sige. Kasi sa weekday mahirap mag-set ng, I believe, ng gantong session because weekday, mas madali pag mag-set ng weekend. What do you think? Sure. Next session, we can have it earlier. At wala nang aberya. Kaya pasensya na ina. Sige. As we were saying, ambiguity tayo, right? We are talking about ambiguity. And we don't want ambiguity because it will make life hard for the compiler or the interpreter, di ba? And the common approach to address ambiguity, kasi ambiguity, saan siya nangyayari? Bakit nagkaroon ng ambiguity? Nasa yung problema natin. The problem lies with the grammar. That's why the approach here, if you encounter ambiguity, we have to modify the grammar. Now, how do we modify the grammar? So let's just make this fast. Mention ko lang yung the ways of addressing ambiguity. So to address ambiguity, we can take a look with operator AP. So this is an interesting question. If operator associativity is correctly described, And associativity means it is where expressions with two or more adjacent occurrences of operators with equal precedence. So like this one, we actually have to specify what kind of associativity the programming now is going to observe. For this one, we indicated here left associativity. Kung mapapansin nyo, if you can observe, the whole of this grammar, this one, this is the same grammar we had earlier. Let me show you. This one, this is our old grammar. Diba? This is our old grammar, and again, I mentioned that we have to modify it. And this is what happened when we modified it. Kita nyo, di ba? So, associativity muna tayo. So, associativity, we indicated here, for this particular example, this is left associative because of left recursiveness. Okay. Now, observing the grammar, do you get this point? Nakasunod ba kayo? Left associativity. In left associativity, the left-hand side, for example, one, EXPR, it should also appear on the left-hand side. Ito yung rule, diba? The whole of this is our rule. So it has to appear here. Yung nasa gilid, the left side. So that's just left associativity. Continue. So if we have left associativity, of course we also have right associativity. Right associativity, the left-hand side, this one, EXPR, should appear on its corresponding position at its right-hand side. Okay? So yun lang yun. Yun yung ibig sabihin ng left associativity and right associativity. And this is one way of addressing the ambiguity problem. And then another approach that we can also use to address the ambiguity problem is through I think I see something here. Operator precedence, sorry, we skipped this one. This is actually, for me, this is more important than operator associativity. So in operator precedence, we are actually defining rules. Now, when we say precedence rules, does it mean? Anyone? Okay, we want to define the precedence rules. Now, what do we mean by precedence rules? Diba? Yes, that's right. Surely, kung alin mauuna i-evaluate or which one is to be evaluated first. Priority. And the root word of precedence is precede. Diba? So kung ano yung uunahin muna na, which operator will go first? That's right. Which operator will precede the other operators? Now, when we define operator precedence, we actually must rewrite the grammar. Okay. Okay, question. If you take a look here in our ambiguous grammar, what is the precedence rules that we have here? Or if I rephrase the question, which operator has the highest precedence? The highest muna. I want to know which has the highest precedence. Yan, iba-iba na yung sagot. So which one has the highest precedence and which has the lowest precedence? When we say highest precedence, Ang highest precedence means which one is to be evaluated first. Okay? Tama, di ba? Highest precedence, the one which is evaluated first. When we say lowest precedence, this is what we are going to evaluate last. Okay, do you want to know the right answer? No one got the right answer. Alam niyo bakit? No one got the right answer. The one with the highest precedence are plus, times, and parentheses. In our example here. Ito, di ba pantay-pantay? Here. Okay, if I may emphasize that. The highest precedence plus times parentheses kasi pantay-pantay sila. Yes or sila. Pantay-pantay sila. They belong to one non-terminal. Okay? Now, question, which operator has the lowest precedence? Yes, based on the given grammar. Which one has the lowest precedence? The one which is evaluated last. Operator ang pinag-uusapan natin, ha? Sige, tinan natin, may makuha ng tamang sagot. Patay. Wala pa na ako ng tamang sagot. Okay lang yan. At least, di ba, nakaklarify na natin right now yung mga misconceptions natin. So, highest precedence, sabi ko kanina, plus, times, and parentheses. Now, lowest precedence, this is evaluated last. Okay, imagine, I'm going to lead you to the right answer. Imagine you have A equals 1 plus 1. Imagine, in your mind, you have the syntax A equals 1 plus 1. Ano yung unang ina-evaluate? Yung per equal sign. Nag-a-add ka ba muna or nag-a-assign ka? Mauna yung plus, di ba? So that has the higher precedence. Now, which has the lower precedence? Obviously, yung huli mong gagawin. Ano yung huli mong gagawin? Huli yung assignment, di ba? Assignment statement. Isn't it right? How weird naman. Inulong mo yung assignments yung bago ka mag-add. So here in our grammar in front of you, which has the lowest precedence? Ulitin yun yung sinabi ko kanina. So, assignment statement, right? Okay, if I may emphasize that, it's here. Okay? Kuha niyo ba yun? Okay. So, in our example here, if I may repeat, the operators having the highest precedence, tayo sila, we have plus, times, and then parentheses. Then the lowest precedence, we have B equals sign. Now, another question that I want you to imagine. Ganito yung tanong ko, If you imagine a parse tree, saan bahagi ng parse nyo makikita yung mga operator na ini-evaluate muna? Can you, saan sa parse nyo makikita sa bandang taas ba or sa bandang baba? Okay, let's go to octave so that you will understand my question. Okay, punta tayo, hanap tayo ng parse tree. Okay. Hanap muna tayo ng parse tree. Ito, parse tree. Okay, question. So, saan nyo makikita sa parse tree yung may highest precedence sa bandang baba o sa bandang taas? Pinakababa, right? Highest precedence, you will see it evaluated in the lower part of your parse tree. How about the evaluate last? Obviously, you're just going to get the opposite of the answer that I've given you earlier. So if we're going to look for the operator which is evaluated last, it should appear on the higher or the highest portion of your parse tree. So if you're going to think of it, medyo biblical to eh. So yung mga nagmamataas, sila yung binababa, di ba? Yung mga mapagkumbaba, sila yung itinataas, di ba? So that you won't forget. It also applies, that biblical principle also applies in your parse tree. Yung mga nagmamataas, mga highest precedence, binababa. Nandun sila sa baba ng parse tree. Di ba? Oh, now, you shouldn't forget what I'm telling you right now. You should hear this. Especially if you probably encounter this in your quiz. Okay, tandaan niyo na yung mataas na precedence sa baba sila nakikita. Yung mga lowest na precedence sa taas. Okay? Let's continue. So that's for ambiguity. And for ambiguity, you either rewrite the grammar using operator precedence or operator associativity. Ito, tingnan na natin dito sa yung rewritten grammar natin. Okay, this is the rewritten grammar in front of you. So here, if we examine our modified or rewritten grammar, which operator has the highest precedence now? Lowest pa rin yung equal sign. Siyempre, di ba? Hindi ka man pwede mag-equal sign muna. So parenthesis. Okay, that's right. Next to parenthesis, we have the multiplication sign, then followed by plus sign. Again, another word of warning, hindi dahil huli kong nilagay dito yung production or yung rule ng may parenthesis, siya na yung may highest. Eh, paano kung jumbuling ko yan? I'm just warning you guys, ha? So my point is you have to examine carefully the grammar rules that you have. Hindi dahil nasa ulo siyang nakalagay, siya na yung highest precedence. Or nasa una siyang nakalagay, siya yung lowest precedence. So you have to examine properly your grammar. So don't be confused, okay? You have to examine properly again your grammar. Okay. Yeah, no, I won't ask you to rewrite the grammar in your quiz. Ibang gagawin natin. Ayan na, isa ng hint or clue. I won't ask you to rewrite the grammar. I will ask you to do something else. Sige, ito. Let's continue. Syntax diagrams are easy, I believe. If then else, skip na natin to. 38 minutes na lang. So I hope by now, before we proceed to semantics, especially axiomatic semantics, you are able to understand better grammar and syntax. Okay, may question muna dito bago tayo mag-semantics. Yung ID na sa baba usually, di ba? Yes, kasi terminals ng production. Yes, that's right. That's right. Tinanong natin for the sake of your classmates. Okay. Yes, ID na yung sabihin natin pinakababa. Kasi ito na yung nagpo-produce ng terminals. Okay, so do you get that sa mga iba nating kaklase dito? So again, the terminals, sila yung nasa pinakababa. Or if we compare it with our parse tree, ito yung leads. Yung leads natin, lagi siyang terminal. Punta tayo, hanap tayo ng parse tree. Ito, parse tree. Di ba? Lahat ng leads ay this one, so on and so forth. Lahat sila ay terminals. Wala ka makita ng terminal ng leads. Kasi yung category sila, di ba? Syntactic category sila. Okay, mali ito Piling ko sa Sabado, maraming mali dito. Okay, let's continue. Semantics na tayo. We proceed to semantics. Anong uulitin ko ron? Ano ron? Ang uulit ko? Yung tanong kanina, yung last statement ko. What was my last statement? I forgot. Okay, what I was saying is leaves. Yung leaves ay yung terminals. Yes, the leaves are the terminals. Wala kayong makitang non-terminal na leaves. Bakit? Kasi nga syntactic category sila, di ba? So, imposible sila mapunta sa dulo. Ano sa dulo ng terminal? Di ba yung terminal, sabihin na terminal illness. O terminal illness, ibig sabihin, ano ba ibig sabihin ng mamamatay na or nasa dulo na ng buhay niya? So, ganoon din dito, di ba? Terminal, nasa dulo. So, simple analogy. I hope that helps, okay? And what I was saying, if you are not that strong or you haven't studied well, there's a great chance you will get confused on Saturday. That's why maganda na punta kayo dito, di ba? Hindi na kayo masyado mali dito. Konti na lang, hindi joke lang. Kaya yan, Saturday. Okay, let's continue. Punta na tayo sa semantics. 5 minutes na lang tayo. The notational semantics. Punta tayo sa axiomatic semantics. Medyo ano to mathematical approach. Logical approach. Logical or mathematical approach. Okay. So alam na natin yung precondition, postcondition. So that is your form. You have a statement, and usually you are given the weakest. You are given the postcondition, and you have to determine, given the postcondition, what is the weakest precondition. When we say weakest precondition, this is we can say the minimum requirement that will make your statement true. Okay? Again, I repeat, the weakest precondition is the minimum requirement which will make your statement true. Or like this one. Your postcondition after forming sum equals 2x plus 1 is sum is greater than 1. So that is what you expect. That is what you expect. Now, if I ask you what is the precondition, you can have several answers, like this one. The first three answers, x greater than 10, x greater than 1000, x greater than 0, they are all preconditions. But when I ask you what is the weakest precondition, I need to have the one which will give us the minimum requirement. Okay? So like this one, the answer is x greater than 0, which is our weakest precondition. Bakit x greater than 0? Bakit yung sagot? Because x greater than 10 it belongs to x greater than 0. Diba? Sakop ng x greater than 0 yung x greater than 10. Am I right? Another thing, x greater than 1000, sakop din ito ng x greater than 0. That's why, minimum requirement, x greater than 0. So, that is your weakest precondition, the one which will give us the minimum requirement. Now, earlier we have a question. The question is, weakest precondition is the close to the postcondition? Not necessarily. It really depends on the statement and on the post condition. Not necessarily same variable, not really post, not really be, sorry. It is not about the matter of closeness, but it is about the matter of satisfying your station. It's about satisfaction, not closeness. I think that's the right or the better term for that. Okay. Sige. Oh, so you want example? Ang daming tanong. Teka, mahina ang kalaban. Isa-isa lang. Sige. Uunahin ko dito. Usually it's an assignment statement, but not always an assignment statement. But usually it is. Okay, so yung mga isa tayong tanong dito. Example tayo. Okay, subukan natin sagutan tong example na to. So okay na tayo ha. I just want you to get the basic idea of having to use axiomatic semantics. Okay, sige ito. Yes, it is possible also to have a sequence. Sige, bago yan, try muna natin sagutan. Sige. So, we have x greater than 10 as your post condition, and your statement S is x equals x plus y minus 3. Okay, before I answer this, Carl, ikaw nga nagtanong, di ba? Before I answer this, what's your answer? I want to know your idea regarding this. So, x greater than 10. So, let's say x is 10. 10 plus y minus 3. Again, dito sa x greater than 10, it does not only denote integer, ha? Kasama rin dito yung, if x greater than 10, x can be 10.0001. Okay? It can also be 10.000002. So it's not only limited to integers, but it includes whatever values, real values greater than the value here. Okay, sige. So, anyone who can answer this in behalf of me? What is the weakest precondition for this statement? Okay, y is greater than 3 daw. Y is greater than 3. Talaga? Sige. Okay, let's say if x is greater than 10, let's say 10. 10 plus y minus 3. So if we have 10 plus 3 minus 3, 10 plus 3 minus 3, what is the value for x? X is not valid, right? So let's say if we have, x 10.001 and y is 3.001. What is the value? So, can anyone compute that for me? Now, let's just try the minimum requirement. So, do you think y greater than 3 is the right answer? Ang ibig sabihin ng statement na ito, yeah, I'm glad that. So, gano'n lang siya. So, actually, you were on the right track regarding your answer. Parang nakulang lang siya ng pag-subtract ng 10. Kasi may 13 ka na dun, di ba? 13 minus 10. So, actually, if we do it the mathematical way of solving it, we can actually arrive with the right answer. But again, there are actually some cases in which those mathematical ways might not work. In that case, you have to think. I mean, pag-iisipan mo talaga. What do I mean by iisipan? I mean, you have to think logically how to solve that. Okay. Sige, let's continue. Doon tayo sa sequence. May nagtanong kayo na sequence daw. Paano ito pag-sequence? This is our example for a sequence. Before the sequence, I'll just give you the idea. It's similar to what we are doing earlier, but here's the catch. For x equals y plus 3, the post condition is x less than 10, right? Isn't it right? For x equals y plus 3 is x less than 10. So we want to compute, we have to compute for the weakest precondition of x equals y plus 3, which is y less than 7. This weakest precondition of x equals y plus 3 will now serve as your post condition for y equals 3 times x plus 1. So that's just the approach to answer, to compute, to get the preconditions. Kita niyo yung connection? So the precondition of the later statement, again, the precondition of the later statement will serve as the post condition of the previous statement. Okay? So do you get that? I hope you do. So it's just a matter of chain reaction. It's just chain reaction again. Ulitin-ulit natin. This one, sige, ganito. You have observed, whenever we solve for the weakest precondition, we always start with the last entry. Right? Hindi tayo nagsisimula sa una. We actually start with the latest entry. That's why what I was telling you earlier, for this example, let's say y less than 7. This is the weakest precondition of this statement. I'm going to change first the color of my pen. Okay. For better emphasis, okay. So this one, y less than 7, I told you that this is the weakest precondition of this one. So this one, the precondition will now serve as your post condition for this one. And to repeat what I was saying earlier, the weakest precondition of the latest statement will serve as the post condition of the earlier statement. Okay? Yes, Q2 is given, and yes, if Q2 is given, we solve for P2, and P2 will serve as Q1. Very good, Carl. That's right. Very well said. Paste natin dito. Paste natin dito. Yan, lagay natin dito. Kasi screenshot nyo, ha? Ay mapindot. Yung, oh. Anyway, questions regarding this before we move on? Dapat tayo matapos. Recursive descent parsing na lang. At yung pairwise disjointness test problema ng iba. Anyway, ano na ang gumana ng text box ko? Okay. Usually, okay, Emil has a question here. Usually, the answer has a numerical value. But there are also, I believe, there are also some cases in which another variable is also involved in the actual answer on the on the right side. Okay? Sige. Parang tanong sa semantics. Shall we move on with RDP, recursive descent parsing? So, 20 minutes left. Kayang-kaya to. Sige. Again, if you have questions and you're shy that your other classmates will see your question, you can send me an email, or if you want your other classmates to see your questions, you can just post it in the forums. Okay? Now we go to chapter 4, finally. Martin, I'll go back to your question later. Sige, ito muna tayo. Let's go straight to syntax analysis. Martin, just remind me later about your question. Syntax analysis. They want to know the reason why I really like to discuss this particular topic. I also mentioned before, chapters 3 are very important chapters. Not only because you need them for your quiz on Saturday, but you are going to need a lot of chapters 3 and 4 concepts for your what? What do you think? For your project, actually. You will need for your final project chapters 3 and 4. And personally, I believe if you can understand very well both of these chapters, you will have an easier time to accomplish your project. And right now, I'm going to tell you about RDP, or recursive descent parsing. Yes, you are going to make your own parser. That's why I'm going to explain this to you, so that you'll know how to make your own parser. Yes, you're going to make your own parser. And to make your own parser, of course, you have to have a grammar first. Chapter 3, grammar. You have to formulate your grammar for your own programming language. Now, if you have a grammar, you have to implement that grammar. And how do you implement the grammar? You need a lexical analyzer. Analyzer produces tokens and lexims, and you can read that later. And also, more importantly, you need to understand and you need to have a parser, or you can also call it syntax analyzer. So we have various kinds of parsers, but one which I would recommend for you to use is RDP, or recursive descent parser, because it's easier to use that. Okay. So let's go to this particular example. So given a grammar, this one. Example na tayo class. So like this one, this is your grammar. EXPR produces term, curly braces again denote repetition, curly braces, then inside of it either a positive or a negative sign, and it is followed by term. Parenthesis ito sa loob. This one just indicates option. You can have a positive or a negative term. Okay. Now, how do you make a recursive descent parser? You have to remember this. For every non-terminal, there must be a corresponding function. Okay? I think I put it here. RDE. Okay. There is a sub-program for each non-terminal. So you have to remember that. So let's go back to our example. That's why we created here void EXPR, which corresponds to the EXPR terminal that we have. And then another rule for here is if you encounter a non-terminal on the right-hand side, here, this is the right-hand side, right? For every non-terminal, you have to call its corresponding function. That's why we have here term. We parse the first term by calling the term function. Ako ba yun? First, again, for every non-terminal, there's a corresponding function or sub-program. We have here term. And then, now, we have the curly braces. I mentioned earlier, we already know that curly braces denote repetition. That's why we have a while loop inside of this. Okay? We have a while loop because of the curly braces. And then next, we have here positive and negative signs. Question. Positive, negative signs are terminals or non-terminals? Positive, negative signs. Okay, that's right. The positive and negative signs are terminals. So, if you encounter a terminal on the right-hand side of the production or of the rule, you actually determine if you have encountered the right terminal. Just like this one. Next token, you compare next token to the plus code. The plus code pertains to the code of the plus sign. And then you also compare it with the minus code. Now, next token contains what? Of course, the next token, right? Oh, right. The next token contains the next token available. Just imagine it is a pointer or a cursor in your word processor that moves. Okay. Now let's continue. Okay, after determining if we have encountered the right token, which can be a positive or negative sign, we call the lexer. Now, anong ginagawa ng lexer? The lexer actually returns the next token, the current value of the next token, and then it moves to the next token. Okay, I'll repeat that again. Medyo malabo ata. So the next token, just like what I mentioned, it contains the next token. Okay, I repeat that again. The next token contains the next token that can be read, or can be read by our, let's say, our program. Now, if we call Lexer, the Lexer will what? It will move the next token to the next token. Okay, kuha niyo ba yun? Just imagine it's a pointer, it moves. Okay, the Lexer will return the current next token, it will move to the next token. Let's say for example we have 1 plus 1. So 1 plus 1, then the current next token is 1. And then after I call Lexer, it will move to plus. So every time that the Lexer is called, it moves to the next token. So do you get it? I hope you get what I'm saying. Yes, it's like a look ahead. Available token. Yeah, you're right. That's right. Do you still follow? So I'm going to repeat two important points. In the right hand side, if you encounter a non-terminal first. If you encounter a non-terminal, you automatically call the corresponding function or subprogram. Okay? And then if you encounter a terminal, you have to compare it to the next token. And after you compare it to the next token, you have to call the Lexer in order to move the next token. It's like a look ahead. Okay? So do you get my point? So that's the basic rule or premise whenever you program using the RDP or recursive descent parsing approach. Okay? Are you still there? Are you fine with that? Okay. I'm happy you got it. Okay, non-terminal. Ulitin ko na, sige. If you encounter non-terminal, you just simply call its corresponding sub-program or function. For example, if you have a non-terminal called EXPR, tatawagin mo na yung EXPR. Yung sub-program. Because just like what I mentioned, every non-terminal has a corresponding sub-program or function. Lagi yun. Okay? Yeah. Because RDP, recursive descent parsing, it uses recursion. Okay, then let's go straight to pairwise disjointness test, and then let's try to make an RDP subprogram for that. So let's go to our example here. Here. Pairwise disjointness test. Okay, this one. Okay, before we proceed, we have a question here. Recursion yung pag-call ng subroutine for each instance of the non. Okay, recursion. Midnight na, sabaw na rin ako. Ulitin ko ulit ha. Okay, we have recursion. In recursion, this is what happens. A subprogram calls itself. Sinatawag niya sarili niya. It can be done indirectly or it can be done directly. For example, you have a subprogram A, right? A, and then in the body of the A function, it calls itself. It calls another A. So that is recursion. Now, another kind of recursion is indirect recursion. Let's say A calls B. Okay, A calls B, and then B calls A. That's indirect recursion. It goes back to itself. And that is also evident in RDP. What if you have several statements, and then you implement an RDP-based programming language? So there is a big probability or possibility that it can call itself, right? Okay, sige. Let's proceed to pairwise disjointness test. Magtutulog na, okay. Sige. Pairwise disjointness test. May nagtanong kayo na, paano ba to? Ganito lang siya kasimple. Pairwise disjointness test, imagine this particular statement. This one, okay? Imagine nyo yan, ha? And then I will ask you to implement an RDP subprogram for that. How do you do that? Ganito, di ba? Yun yung rules for... No, we don't need to specify the rules for B. We can actually make an RDP subprogram for that. For A. We'll just simply call B. Okay, so... Sige. Ito yung tsura niya. This is for the second production or second rule. Gagawin natin, di ba? If next token... This is our approach, right? Next token... Sorry. Is equal to, say, A code. A code. So what's next after this? So may A code ka, di ba? Now, how are you going to differentiate A and AB? For the first example, it is easier to differentiate A, B, and C, right? Because you're just going to compare next token with A code, with B code, with C code, right? Am I right with that? For the first example, this one, it's easier to differentiate them. But for this particular example, this one, as you can see here, how do you differentiate A and AB? We can't, right? The pairwise disjointness test fails in the second example. Kasi may magkakapareha sa una. Regarding your question, Sin, B is not a terminal, and we can actually make that assumption. Let's just focus on the production which is here in front of you. So, by simply observing and analyzing this particular rule, can you say? Yes, that's right, Carl. The first terminal that can be read is the same for both productions. If it is the same, then that grammar rule fails the pairwise disjointness test. In short, sa Tagalog, kung may magkakapareha sa umpisa nila, bagsak na, 5 na sa pairwise disjointness test. Dapat hindi sila magkakaparehas. Okay? Ang usual convention natin dito, Derek, if you have capital letters, they are actually represent non-terminals. But don't worry, for the quiz or for convention, as a matter of convention, we have to use the greater than and less than signs. But for this particular example, let's just assume B is a non-terminal. Okay, so let's continue. So how do we address the pairwise disjointness problem? So to address this, okay, how do we pass? This is the first approach. So the first approach is we actually factored out. Kung alam niyo sa math, diba, nagpa-factor out tayo. So you get the common factors and then you define another rule. So, dito ba dito sa in front of you? So this is the first approach. We do left factoring. We factor out. And then another approach is we use another notation from extended BNF. Extended BNF is in this chapter earlier. So for extended BNF, you can use these meta symbol, the square brackets meta symbol, which means it is optional. Okay, so questions? So are we good? See, regarding your question, these are two distinct examples. I just want to ask you which of these two will pass and which of these two will fail. For example purposes, I just want to ask you, ito bang una, nakapasa ba siya? Yung pangalawa ba, bagsak siya? So, they're different, okay? Sige. So, we have 4 minutes left and good morning. We're past midnight. Wow, 2 a.m. Good morning. Since we have less than 4 minutes left, perhaps we can ask me quick questions. Again, the second part of this session is recorded. In the first part of the session, I believe someone recorded this. And if you have questions if you have questions this coming days, you can just simply email me or post them in our forums. Mukhang sabaw na yung mga tao. Again, thank you for recording the first part of our session tonight. Sige. Ang daming tanong. Sige. Wait lang, isa-isa lang yung nakalaman. You don't test the empty string because it's empty. Wala ka namang itetest doon. How many items is the quiz? I don't know. Masa-surprise na lang kayo. And then, how long is the quiz? Just like before, I'm just going to make it available the whole day of Saturday, and then since it is quite long, I'll give you at least 45 minutes to finish your quiz. So, thank you for coming to our sessions. Kahit kanina maraming aberya, at least we were able to finish it. Again, the screenshots, kindly share them to your classmates para yung mga hindi nakapunta, at least meron silang reference. No, we won't include them. Gusto mo? Shift reduce algorithms? Yung buong table? Joke lang, sige. They're not included. Basta sure na kasama yung pinag-usapan natin tonight. Yung diniscuss natin tonight, syempre meron din kasama na basta walang shift reduce. Syempre may objective part. There's an objective part in the quiz. Thank you then, and have a great week ahead. Kita-kits soon for another session. I-announce lang natin sa my portal. So thank you then. I'm also looking forward to our next session. So we have 17 seconds left. Good night or good morning. God bless everyone. Till next time. Bye.